What is going on, everyone? Welcome back to the Blackboard. In this example, we're going to be looking at complex eigenvectors and eigenvalues, just to show you that the process of it is much more simpler in a way, and also no different than the regular real eigenvalues and eigenvectors. So let's get started with this one. So this first example, we have a 2 by 2 matrix, and we are asked to find the eigenvalues. So finding the eigenvalues, as always, you need to find the characteristic equation. So the characteristic equation will be lambda squared minus -1, so be plus 1 is equal to 0. And right here, you can already tell that our solution is going to be complex, since our eigenvalue is going to be plus or minus I. And so to find the eigenvectors, as I mentioned in the lecture, you don't have to find the eigenvectors for I and negative I. All you have to do is just find one of them and take the complex conjugate. So we're just going to focus on the positive I. So we're going to let lambdas equal to I. So this gives us a matrix of negative I on -1 and negative I. And we can do reduced echelon form, but we can also eyeball it. And a quick little note, as you get more complex eigenvalues, it becomes harder to eyeball the solution. So at that point, you kind of have to do row reduction. And so for this one is fairly simple. If we look at the bottom one, we have 1 and negative I. So we can just multiply the first one by I, and then keep the other one as just 1. So it'll be I minus I, and then we can see it will agree with the second, not the second one, the first one, which would just be 1 minus 1. And this is our eigenvector for the first eigenvalue. For the second, like I said, we technically already found the second eigenvalue. So all we have to do is just take the complex conjugate, which is just flipping the signs of any imaginary number. And that's pretty much it. So for the second example, we are given this time a 3 by 3 matrix. Again, I'm going to do the whole characteristic equation first. And because we have a lot of zeros, we are going to do, it doesn't matter which one, this one or this one, but I'm going to do the bottom one. So we have 0, 0, 0, or 0, 0, and then 3 be 3 minus lambda multiplied by lambda squared plus 1, and that's equal to 0. So we have our eigenvalues to be 3, and then again plus or minus I. And so we can just get rid of the first one. So when lambda is equal to 3, we will get a matrix of -3, 1, 0, 0, 0, 0. And so that this will give us a eigenvector of 0, 0, 1. And then for the lambda is equal to, again, we're just going to look at one of them, when it's equal to I, we will get negative I, -1, 0, 1, negative I, 0, 0, 0, 3 minus I. And so when we find our eigenvector for this one, this would be equal to, again, we can just keep we can technically just zero out the third one, and then have the first one being I, and then -1. And so for our lambda is equal to negative I, we will get V is going to equal to -I, -1, 0. and those will be the eigenvectors for this 3x3 matrix. Alright, so now let's move on to the last example. And so this one again is going to be a 3x3 matrix. And so as usual, we are going to find the characteristic equation. So we can find our eigenvalues. And so we're going to use this top row since we have a 0. So it will make our lives a little bit simpler. And this would be 36 plus 9, negative 1 minus lambda. We do a little bit of simplification. This would be lambda squared plus 2 lambda minus 7. And this would be 27 minus 9 lambda. And so we end up getting this 3 minus lambda. This portion is copied down. Oh, this is a plus. Plus factor out a 9, so we'll have 3 minus lambda. And we can factor out those, getting 3 minus lambda. And then we'll have lambda squared plus 2 lambda plus 2. And so we'll have our eigenvalues being 3, and then for this one we can just use the quadratic equation. So it'll be negative 2 plus or minus 4 minus 8, negative 4 all over 2, giving us negative 2 plus or minus 2i over 2, or negative 1 plus or minus I. So now we are going to plug in our eigenvalues to find the eigenvectors. So for this one, it will be 0, 9, negative 9, 0, negative 4. I forgot the other rows. 4, and then 1, 2, negative 4. And so for this one, our eigenvector will simply be, to zero out this one, this just has to be a 0. So this goes away. We have 9 and 4, so that'll be 4 and 9. So that'll be our first one. And then our second one, it would be negative 1 plus I. And again, all we have to do is just find the eigenvalue for this one. So we find the eigenvalue for the other one. And this will just be 3, 4 minus I, 9, negative 9, 0, 1. This would be negative I, 4, 2, negative I. And so how do we find the eigenvector for this one? So clearly we can't eyeball it because it's a little bit hard. And so one way you can do it is if your matrix does not have a 0, you kind of have to do row reduction to get a 0, and that's all you really need. So in this case, we got lucky and we have our first row containing a 0. So what we can effectively do is have instead of 3 variables, we'll have 2 variables. So we have 4 minus I multiplied by x plus 0 plus z is equal to 0. And so what you'll tend to do, anything that has any variable that contains the imaginary number, will tend to keep that variable 1. So x is equal to 1. So to cancel out the 4 minus I, you just multiply everything by negative. So this will be negative 4 plus I. And then after you do that, you just pick any of the other 2 equations so you can find your last variable. So in this case, I'm going to use the second one. So we'll have 9 times 1, and then minus IY plus 2 times negative 4 plus I. So this will give us 8. So this will be 1 plus 2i minus I times y is equal to 0. And so our y will be 2 minus I. So 2 minus I. And then for the other eigenvalue, the eigenvector will simply be the complex conjugate of the one that we just found. So it'll be 1, 2 plus I, and then negative 4 minus I. And that's pretty much it for this video. Again, for this particular part, for part C, once we start having complex values, it becomes harder to eyeball our eigenvector. So what we'll tend to do is zero out a value so we can just deal with two variables, and then we find the third variable just using the any other equation. Again, you have to do row reduction, and like I'm pretty sure 100% of the cases you'll want to zero out a real number. So if this one wasn't 0, so let's say this was like 2, we will want to either zero out these two, or one of these two, or one of these two to make our lives easier. It will more likely be these two because you can just add them together. And so we'll have a 0 and then just continue with the two variables and then figuring out our third. But other than that, thanks for watching, and I'll see you in the next video.